Getting things done on a busy worksite requires plenty of energy, and a lot of that energy is electrical. Electricity powers most of the tools and equipment that you use. It lights your work area. It can even help keep you cool on the job. But using electricity all the time makes it easy to forget that it can cause painful shocks, burns, even electrocution. Every year, hundreds of deaths and injuries in the construction industry are caused by electricity, but most of these incidents could have been prevented. In this program, we will discuss the hazards of electricity, the federal standards that have been established to protect you from those hazards, and what you can do to work more safely with electricity. Electricity helps us to accomplish a lot. But when it gets out of control due to faulty equipment or unsafe work practices, electricity can also create serious hazards. More than 100 construction workers are killed by electricity each year, making electrocution the fourth leading cause of death in the construction industry. And construction workers suffer more than half of the electrical injuries that occur on the job. To address these hazards, the Occupational Safety and Health Administration, OSHA, has established electrical safety standards for construction as well as for general industry. These standards are based on the National Electric Code, NFPA 70E, created by the National Fire Protection Association. One of the things the OSHA regulations emphasize is the importance of employee training. Workers are required to receive training on the electrical hazards that they encounter on a job site, as well as their employer's responsibility to provide protection from those hazards. OSHA has defined 6 general types of electrical hazards. To make them easy to remember, their initials spell out the phrase, "Be safe." B stands for burns, which are a common shock-related injury. They can be caused by exposure to electric current, being close to an arc flash, or contact with a surface that's been heated by an electrical overload. E stands for electrocution, which means being killed by exposure to a lethal amount of electricity. S stands for shock. Shock occurs when electricity courses through part of your body. A stands for arc flash, a violent electrical explosion that occurs when an electrical system is disturbed so that the energy suddenly leaps through the air like lightning. Arc flashes are particularly dangerous since they can create heat as high as 35,000 degrees Fahrenheit, light that is bright enough to burn the skin, deafening noise, and a pressure wave or arc blast that can break bones, damage internal organs, and blow a person across the room. F stands for fire, which can be caused by cords, wiring, receptacles, and switches that are faulty or overloaded by too much current. E stands for explosions. These can occur when electricity creates sparks that ignite explosive or flammable vapors or dusts in the air. That's a pretty grim list, but to help you avoid these hazards, OSHA has also identified the most common ways that construction workers can be exposed to them on a job site, so you'll know how to protect yourself. The list includes contact with overhead power lines, contact with energized sources, such as exposed electrical components and faulty or damaged equipment and tools, and the improper use of extension cords and electrical connectors. The amount of electricity carried by a high-voltage power line can range from 120 to 750,000 volts. So the first time you touch one is usually the last. Accidental contact with overhead power lines on job sites is a major cause of electrocution among construction employees. So OSHA has established specific safety standards to address this hazard. About 20% of power line electrocutions occur when workers themselves touch a power line. But even more occur when the tools and materials that they are carrying or the equipment they are operating either touch the lines or get a little too close to them. If you're carrying an aluminum ladder or length of rebar, operating a boom crane or dump truck, or working from a man lift, you can be killed by electricity jumping to them and then to you. Even if a metal ladder just gets too close to a power line, it can act just like a lightning rod. So you should always use ladders that are made of a non-conductive material such as fiberglass when working around utility lines. While power lines do have protective coatings, they are there to protect the wires from the weather. They won't protect you from the electricity in the lines. So whenever possible, arrangements should be made with the utility company that operates the lines that are on a job site to de-energize and ground them. If they cannot power down the lines, they may be able to install insulated sleeves over them to provide some degree of protection. But for live power lines, it's also critical to determine how much voltage is being carried in the lines. That number will tell you how far you need to stay away from the lines to avoid electrocution. If you don't know the voltage in a line, you should assume that it's enough to kill you and stay at least 10 feet away. When you do know the voltage, you can use the table in OSHA's electrical safety standards to determine the safe working distance. This distance increases as the voltage increases. Flagged warning lines, caution tape, and signs should always be set up to mark both the horizontal and vertical safety limits around overhead wires. High visibility markings, spotters, barricades, and other devices should also be used to prevent vehicles and equipment from getting too close to them. If you ever have questions about how to work safely around overhead power lines, ask your supervisor. But not all power lines are above ground. Like other utilities, electric power lines are sometimes buried underground. Accidentally coming into contact with a buried line when using a backhoe, auger, or other digging device can lead to fires, arc flash explosions, even electrocution. Water in trenches around buried wires can also create serious electrical hazards. So before work begins on any construction site, you should contact the 811 Call Before You Dig number to determine whether any utility lines are buried there, and if so, where they are located. If there are utilities on site, the company that operates them will send a locator to mark where the lines run. It's important to find and understand these markings before you start digging. Excavation should always be performed with caution around the lines and hand tools used within 3 feet of them. And remember, there may be more than one line buried in the same location. Construction work is demanding on both people and equipment. It can cause serious wear and tear on electrically powered hand tools and extension cords, as well as the receptacles that they plug into. Cords fray, insulation cracks, and parts wear, break, or get lost. Unauthorized alterations and amateur repairs can make things even worse. Eventually, tools and equipment that used to be safe can expose workers to shocks, burns, and electrocution. But you can avoid these hazards by following the safe work practices that are included in OSHA's electrical safety standards. These begin with a careful inspection of electrical equipment before you use it. Check tools for cracked housings, loose or missing parts, and rust or corrosion. Inspect the tool's power cords for fraying, cracked insulation, and exposed wires. If you find problems with a tool, do not use it. Take it out of service and replace it. When using electrical tools, you should always follow the operating instructions that have been provided by its manufacturer. Also remember to never carry a tool by its cord. Keep your fingers away from the on-off switch until you're ready to use it. Unplug the tool before changing blades or bits or performing other maintenance. And put the tool away, unplugged, in a dry place when you're done. Before using extension cords, you should inspect them for fraying, damaged insulation, and exposed wires as well. Only heavy-duty grounded cords with 3-prong plugs should be used on a work site. Never use homemade or makeshift extension cords made with Romex wire or receptacle boxes that were designed to be mounted on studs in a wall. To avoid damaging electrical cords, you should protect them from rough surfaces and sharp edges, excessive strain and heat, and exposure to oil, which can degrade the insulation. Never yank on a cord to remove its plug from a receptacle. Pull on the plug itself. And never remove the ground prong from a plug or use an adapter as a quick and easy way to connect a 3-prong plug to an ungrounded 2-prong outlet. Proper grounding helps protect you from being injured or killed by stray electricity. If you find a grounded plug with the 3rd prong removed or an adapter being used without the ground wire connected to the receptacle, take that equipment out of service at once. You should also avoid plugging multiple cords into a single receptacle. Drawing too much current can overload the circuit, heat up the wiring, and possibly start a fire. A receptacle that is missing its faceplate can expose you to live wires and other energized parts as well. If you encounter one of these, don't plug anything into it until a faceplate has been installed. Since construction work can take you to a variety of different types of work sites, it's important to remember that water can increase electrical hazards. Since it conducts electricity, water that gets on or into electrical equipment can lead to ground faults, shocks, burns, and worse. So you should avoid using electrically powered tools or extension cords in wet or damp environments. If you must work in the wet, be sure the tools you use are double insulated, and never plug in anything that has water on it or in it. Finally, if you're going to use portable electric tools and cords outside, make sure beforehand that they are rated for outdoor use. Most of the time, electricity flows in circular systems called circuits. But if something interferes with the circuit, such as when an extension cord frays and exposes a live wire, the energy will try to find the shortest and easiest path to the earth, which is called ground. Electricity jumping out of a circuit to ground is called a ground fault. If the current surges through your body on its way to the earth, ground faults can cause shocks, burns, even electrocution. To protect construction workers from these hazards, OSHA's electrical safety standards require employers to implement an Assured Equipment Grounding Conductor Program, AEGCP, on their job sites, or to equip the sites with devices called Ground Fault Circuit Interrupters, GFCIs. To understand how these two options reduce electrocution hazards, it helps to know a little more about grounding. One way to protect people from being electrocuted by electricity that is trying to jump to ground by going outside of the equipment that they are using is to provide a safe path to ground on the inside of the devices. Power tools, cords, and receptacles that have this feature are called grounded equipment and will always have 3 prongs on their plugs or 3 holes in the receptacles. If problems cause any electricity to leak in equipment that is grounded, it should jump to this internal ground. But to make sure that this happens, the internal ground connection has to be continuous. Continuous means it has no gaps or restrictions that could prevent the stray energy from flowing easily all the way to the earth. This is where the Assured Equipment Grounding Conductor Program, or AEGCP, comes in. An employer that chooses this option must create and implement a program to ensure that the ground connections on each of their job sites are continuous. The program designates qualified personnel who test tools, equipment, cords, wiring, and connectors for grounding continuity on an ongoing basis. A copy of the written program must be made available on each job site, and results of the testing must also be kept on file. However, on some job sites, it may not always be possible to ensure that a continuous ground connection is available in all areas or for all equipment. So, as an alternative to an assured grounding program, OSHA also allows employers to protect against ground fault hazards by using ground fault circuit interrupters, GFCIs. GFCIs can provide protection against leaking electricity and short circuits without a continuous ground connection. Built into receptacles and extension cords, GFCIs monitor the flow of current in a line so they can sense when the electricity is trying to jump to ground. Then they act like circuit breakers, cutting off the power in as little as 1/40th of a second. This prevents the stray electricity from damaging anything or anyone. GFCIs can also be built into the breakers on a main fuse panel to protect workers from ground fault hazards on entire circuits. Swapping out drill bits or saw blades, cleaning and lubricating moving parts, performing any of the maintenance or repair tasks that electrically powered equipment can require throughout the day. To accomplish any of these things safely, you first need to shut off the electricity that powers the equipment. And the electricity has to stay off while the work is being done. Switching the power back on could seriously injure, even kill the person servicing the machine, either because of the sudden flow of electrical current or the moving parts that it sets in motion. To prevent this from happening, OSHA's electrical safety standards require workers to follow lockout-tagout procedures, so that when power is shut off, it can't be restored until it's safe to do so. Lockout-tagout begins with identifying all of the sources of energy to the equipment that needs to be serviced and determining how they should be shut off. This includes any backup power sources, such as generators and batteries. All workers who will be affected by the shutoff, such as other employees who use the machinery or the power from the circuit that it's on, should be informed that a lockout-tagout is being performed as well. The energy sources should be turned off and locks applied to secure the switches in the off position. Only dedicated lockout-tagout locks should be used for this purpose. Padlocks that just happen to be available are not permitted. In some situations, several people can be involved in locking out power sources. In these cases, each of them should apply their own locks. Special lockout devices are made that allow multiple locks to be attached to a single switch. The equipment that is being worked on and its electrical circuitry should then be tested by a qualified person to verify that the power is truly off. OSHA defines a qualified person as a worker who is familiar with the construction and operation of the equipment, as well as the hazards that can be associated with it. The qualified person should also release any electrical energy that has been stored in the equipment, such as in charged capacitors. Once the equipment is completely de-energized, a special tag should be filled out and attached to the switch along with the lock. The tag explains that lockout-tagout procedures are in effect, why the equipment has been powered down, and who is involved in the process. At this point, the maintenance or other service tasks can be performed safely. When the work on the equipment is complete and all workers are physically clear of the equipment, the qualified person will determine if it's safe to restore power. Tags and locks can then be removed. When multiple locks have been used, each of them must be unlocked by the person who originally applied them. The power can then be turned back on. Even if you're not personally involved in performing lockout-tagout, you can help to ensure the safety of your coworkers by remembering this. If you encounter a power source that has been locked out, you should never attempt to remove the lock or turn anything on. As we've seen, electricity can create serious hazards on a construction site, but there are ways to prevent any incidents from occurring. Let's review. Electrocution is one of the leading causes of death among construction workers. To address electrocution and other electrical hazards, OSHA has established electrical safety standards for the construction industry. OSHA has also identified the top 3 causes of electrocution on construction work sites. contact with high-voltage power lines, contact with energized parts due to faulty or damaged tools and equipment, and the misuse of electric cords and connectors. OSHA safety standards require employers to protect their employees from electrical hazards on the job. The standards also include safe work practices that employees should know and follow whenever they work with or around electricity. Now that you understand the hazards that electricity can create on a construction site and know the equipment and procedures you should use to prevent accidents and injuries, you can help to ensure that you and your coworkers go home safe at the end of every day. Electrical energy helps construction employees do a lot of useful work on a job site, but it can create serious hazards for them as well. Electricity kills more than 100 construction workers each year, making electrocution the fourth leading cause of death in the industry. And construction workers suffer more than half of all the electrical injuries that occur on the job in this country. To help employers ensure that their employees can work safely with and around electricity, the Occupational Safety and Health Administration, OSHA, has established electrical safety standards for general industry and construction. In this program, we'll look at the different types of electrical hazards that can be encountered on construction sites and the OSHA regulations that address them. We'll also discuss the responsibilities that construction employers have to protect their workers from these hazards. Getting things done on a construction site requires a lot of energy, and a lot of that energy is electrical. Electricity powers most of the tools and equipment that construction workers use. It also lights our work areas. It even helps us keep cool on the job. But electrical energy can also be dangerous. It can cause painful shocks, burns, even electrocution. Every year, electricity is involved in hundreds of deaths and injuries in the construction industry. But most of these incidents could have been prevented. To address electrical hazards, the Occupational Safety and Health Administration, OSHA, has established electrical safety standards for the construction industry. Like all OSHA rules, these require employers to ensure that their workplaces are free from recognized hazards that are causing or likely to cause death or serious physical harm to employees. OSHA's electrical safety standards for construction require employers to isolate the electricity in a worksite's energy control and distribution systems, restrict access to high-voltage equipment, implement an assured equipment grounding conductor program on each job site, or equip the site with ground fault circuit interrupters, GFCIs. The standards also require employers to ensure that portable electric tools and cords are properly used and maintained, take precautions to reduce electrocution hazards when work is performed near overhead power lines, and ensure that lockout-tagout procedures are followed when workers are servicing electrically powered equipment. The OSHA standards also emphasize an employer's responsibility to provide training for all employees on the electrical hazards they can encounter, as well as the equipment and safe work practices they should use to avoid those hazards. Finally, employers should supply their employees not only with personal protective equipment that is appropriate for the electrical hazards on their job site, but also with training on how to use, inspect, and maintain that equipment. Overhead power lines can carry up to 750,000 volts of electricity, so coming into contact with one, or even just getting too close to it, can be fatal. Among construction workers, power lines cause more electrocutions than any other electrical hazard. Under OSHA's electrical safety standards, construction employers must ensure that strict safety precautions are taken whenever power lines are present on a job site. Even before work begins on the site, the utility company that operates the power lines on the site should be contacted so that the wires can be de-energized and grounded. If the lines cannot be powered down, the utility company may be able to provide some protection from the energy in the lines by covering them with insulating sleeves, also known as eels. Contractors should also find out how much voltage is being carried by the lines. That information can be used to determine just how much clearance workers must give them to avoid electrocution. As a standard operating procedure, employees should always assume that power lines are carrying a lethal amount of electricity and stay at least 10 feet away from them. For extremely high voltages, even greater separation is required. This safe working distance also applies to tools or materials that they are carrying, as well as equipment, such as trucks, cranes, or lifts that they are operating. To prevent anything or anyone from getting too close to a power line, the safe working distance should be marked off both horizontally and vertically from the wires. The equipment that is used for this purpose, such as flagged warning lines, caution tape, and barricades, must be provided by the employer. Workers should be fully informed about the hazards that are associated with power lines and the precautions that are being taken to reduce those hazards on their site. Their employer should also provide them with appropriate personal protective equipment and make sure that they wear it. Saws, drills, hammers, nailers, portable tools like these that are powered by electricity are in constant use on most construction work sites, and so are the extension cords that supply many of them with power. Over time, hard use, misuse, and unauthorized alterations can cause that equipment to become electrically hazardous. As a result, power tools and cords are involved in a significant number of electrical accidents, injuries, and fatalities on job sites. That's why OSHA requires construction employers to provide training for their workers on proper maintenance and use of electrical power tools and cord sets. Employees must understand that safe practices should begin before any equipment is used, with a thorough inspection for wear or damage. Tools should be checked for cracked housings and loose, bent, or missing parts. Power and extension cords should be examined for exposed wires, cracked insulation, and any signs of fraying. If problems are found, the faulty equipment should be taken out of service for repair or replacement. Employers must also make sure that all tools and cords on a site are heavy-duty types that are grounded, rated for outdoor use if necessary. Proper grounding is very important in preventing electrical accidents and injuries. Anytime the circular ground prong has been removed from a 3-prong electric plug, that equipment should be taken out of service. Even tools and cords that are in good condition can hurt or even kill people if they're misused. So OSHA requires contractors to ensure that their employees operate electrical equipment according to the instructions that were provided by the manufacturer and follow safe work practices at all times. Before changing out bits or blades or servicing them in any way, tools should always be unplugged. Since water conducts electricity, using electrically powered tools and extension cords in wet conditions should be avoided whenever possible. When working in the wet is unavoidable, the tool should be plugged into a ground fault circuit interrupter. Workers should also know to wear appropriate PPE, including rubber-soled boots and rubber gloves. Electricity is pretty safe when it stays inside the circuits it's supposed to run through. But when those circuits become worn or damaged, or when they are misused, the current can jump out of them trying to find its own way to ground. This is called a ground fault. Electricity will always seek the shortest and easiest path to ground, and if that path happens to lead through a person, they can experience a shock, a burn, or even be killed. OSHA's electrical safety regulations give construction employers two options for protecting their employees from ground faults. One is to create and implement an Assured Equipment Grounding Conductor Program, AEGCP, for each job site. The other is to equip each site with Ground Fault Circuit Interrupters, GFCIs. In an Assured Grounding Program, designated employees inspect and test electrical equipment on the site regularly to ensure that it is grounded. This helps ensure that any electricity that leaks in faulty equipment can find a safe internal path to ground instead of shocking and possibly electrocuting the person using it. An AEGCP will monitor all cord sets on a job site, all receptacles that are not part of the permanent wiring of a building or structure, and all equipment connected by cords and plugs that employees can use. OSHA regulations require a copy of the written Assured Grounding Program to be available on the worksite and records of the continuity testing to be maintained as well. In some situations, however, it may not be possible to ensure proper grounding on a worksite. So as an alternative to an Assured Grounding Program, OSHA also allows construction employers to equip their job sites with ground fault circuit interrupters. An important advantage of GFCIs is that they can perform their safety function even when a continuous ground connection is not available. Built into receptacles and extension cords, GFCIs monitor the flow of current in a line to sense when electricity is jumping to ground. Then they work like circuit breakers, cutting off the power in the line in as little as 1/40th of a second. GFCIs can also be built into the breakers in an electrical panel to provide ground fault protection for entire circuits on a site. For electricity to be used safely and effectively on a construction site, it has to be distributed to different locations on the site and controlled by devices that turn it on or off as needed. OSHA has established safe work practices for power distribution and control that contractors must follow to reduce electrocution hazards on their job sites. These include energy isolation, equipment guarding, and lockout-tagout procedures. Energy isolation ensures that electric current stays safely inside the wires, electric panels, junction boxes, and other equipment that distributes it throughout the site. To prevent damage, wiring should be protected from sharp edges and abrasion wherever it enters panels, boxes, or other fittings. To prevent exposure of energized components, any unused openings in these boxes and fittings should be closed off. A cover or faceplate should be installed, and if the parts are made of metal, they should be grounded as well. High-voltage electrical equipment such as transformers, switchgear, and distribution boxes can create serious electrocution hazards, especially for workers who are not familiar with how they work. So equipment rated at 50 volts or higher is kept separate or guarded on a job site. This allows access to be limited to those who are qualified and authorized to work with the equipment safely. Equipment can be guarded by locating it inside an enclosure or behind permanent screens, in special rooms, vaults, or galleries, or on a balcony, elevated platform, or other place that is 8 feet or more above the ground. While guarding and isolation can reduce hazards associated with the distribution of electricity on a worksite, lockout-tagout procedures focus on where that energy is used. Whenever electrically powered equipment needs maintenance or repair, its power should be turned off before the work is performed, and that power has to stay off until it's safe to re-energize the equipment. Restoring the power too soon could result in the person who is servicing it being injured, even killed, either by the sudden flow of electric current or the moving parts that it sets in motion. To prevent this from happening, lockout-tagout procedures standardize the steps that are followed in the power control process and physically lock a power switch in the off position until energy can be restored safely. A tag is applied to the locked switch, which explains why the power has been shut off and who is doing the work on the equipment. Construction employers must ensure that lockout-tagout power control procedures are followed on their work sites. They are also responsible for supplying the specialized equipment that is required for lockout-tagout, as well as the training that employees need so they know how to use it. This training should emphasize that when a worker encounters a power switch that has been locked and tagged, they should not tamper with the lock or try to restore the power. As we've seen, electricity can create serious hazards on a construction site, but employers can help their employees avoid these hazards by following OSHA's electrical safety standards. Let's review. Electrocution is one of the leading causes of death among construction workers, and electrical accidents result in thousands of job site injuries. To address these hazards, OSHA has established electrical safety standards for construction to help prevent electrical accidents, injuries, and fatalities. The OSHA standards require construction employers to ensure that their work sites are free from recognized electrical hazards that are causing or likely to cause death or serious physical harm. Employers must ensure that precautions are taken on each job site to reduce electrical hazards as much as possible. Implementing an Assured Equipment Grounding Conductor Program, AEGCP, or installing ground fault circuit interrupters, GFCIs, are both OSHA-approved safety approaches to keeping an electrically safe worksite. Employees must be provided with the equipment and training in safe work practices that they need to avoid electrical hazards on the job. Now that you understand the electrical hazards that can be encountered on a construction worksite and the responsibilities that your employer has to protect you from those hazards, you can help ensure that you and your coworkers can go home safe at the end of every day.